Hey everyone, today we are going to solve the LeetCode question, range sum of binary search tree. Okay, so as you may know, typical binary search tree is like left side is less than a root node, and the right side is greater than root node. And we have to add numbers between low and high. So that's why if root dot var is less than low, so in that case, current root node is out of bounds, right? So in that case, we want bigger number. So that's why we should go to right side. And on the other hand, so root dot var is greater than high. Not high, high. In that case, so also current root var is out of bounds, right? So in that case, we want smaller number. So that's why we move left side. And if we don't meet this condition, so in that case, that's a number we should add. So that's why we should return root dot var and plus. So we have to add left side and the right side, right? So left plus right. And there's actually one more condition. So it's about a null. So if we find a null, so that means null is actually equal to 0, right? Because there is no number. So that's why we have one more condition. If not root, in that case, we should return 0. So okay, let's see how it works. So low is 7 and high is 15. So we start from root node. And first of all, root is not null, right? So we skip this condition. And the root var is now 10 and the low is 7. So we don't meet this condition, right? So skip. And the root is now 10 and the high is 15. We don't meet this condition, right? So in the case, so 10 is one of numbers we should add, right? So 10. And then, so we have to add left subtree, I mean here, and right subtree, and here. So we go to left side. So now root is 5. So root is not null, right? And then now root is 5. And in that case, low is 7. So 5 is less than 7, right? In that case, we meet this condition. So 5 is actually out of bounds. So that's why we should go to right side to get a bigger number. So from 5, we go to right side. That means 7, right? So next root should be 7. And root is not null, right? And now root is 7. And 7 is less than 7. So it's false, right? We skip. And root is now 7 is greater than 15. So it's false, right? So we don't meet these two conditions. So that's why, so 7 is also one of numbers we should add. So 7. And then 7 plus, and we have to go to left and right. So from 7, so we should go to left side and the right side. But as you can see, so let me skip our explanation. So both sides is null, right? So in that case, even if we go to left side, right side, we should return 0, right? So that's why 7 plus 0 plus 0. So total 7, right? So this is our left side. So if when root is 10, so left side should be 7. Plus, so now we go back to our root node and go to right side. And then in the case, so we find 15. So now root is 15, a little bit messy. And so 15 is less than low 7. It's false, right? So skip. And then 15 is greater than 15. False, right? So that's why 15 is also one of the numbers we should add. So 15. And so we have to add left side and the right side from 15. So that means this side and this side. And as you can see, left side is 0, right? So plus 0. So we should return 0 here. And about the right side, so we have numbers 18, but 18 is, so now root is 18, so not null, and 18 is less than 7, it's false, right? And 18 is greater than 15, that's true, right? So we should go to left. But left is 0, right? Null. So that's why we should return 0. So right side of 15 is 0, right? So total should be 15 plus 0 plus 0, and 15. So this is the right side of 10. So that's why our right side of 10 is 15. So in the end, so total should be 10 plus 7 plus 15. So that is 32, right? 10 plus 7, yeah. So we should return 32 in this case. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, so let's write the code. First of all, so if not root, in the case we should return 0, right? And we have another two conditions, right? So if root.var is less than row, in the case we should go to right side, right? So return self dot, so let me copy this, range sum binary search tree, and root dot right, and we should pass row and high. And another condition should be if row, not row, root.var is greater than high. In the case, so let me copy this. So we should go to left side, right? Because we want smaller number. And then, if not the case, we should return root.var plus, so we should add left subtree and right subtree. So self dot, and so this one, and root dot left, and row and high plus, so this is the left side, and this is the right side. Yeah, that's it. So let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n, where n is the number of nodes in the binary search tree. So in the worst case, but if binary search tree is an unbalanced tree, like a skewed tree, so there is a possibility that we have to visit all nodes, which is n. And the space complexity is order of h, where h is height of binary search tree. So in the worst case, recursion depth is equal to height of the tree. So the space used on the call stack during the recursion is proportional to the height of the tree. So that's why. Yeah, so that's all I have for you today. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question.